to our second portion of the entire course, which is the vectors portion. So we will start with section 6.1, which is an introduction to vectors. Math, we encounter different quantities with different magnitudes and directions. When we encounter a quantity that has only magnitude, we specify them into what we call scalars. Scalars do not have directions, only magnitude, and some examples to scalars can be age, volume, area, speed, mass, temperature. If we think about it, temperature doesn't have a direction, it only has a magnitude. Same thing with volume. You don't see a direction in it. The only thing you might be confused about is speed. However, speed is differentiated by velocity. Speed does not have a direction, while when we add direction to speed, it becomes velocity. However, there are also some quantities with magnitude that also has a direction, like I mentioned, as speed. These are specified into vectors category. Some examples can be weight, velocity, friction, etc. And you might be asking, how do I differentiate these two categories in a problem, right? Well, an example can be a problem mentioning if an airplane is traveling at a speed of 500 kilometers per hour. I can already tell this is scalar because it says speed over here. So make sure you check the wording. However, if the problem added saying the airplane is traveling in a northeasterly direction, then this indicates direction, and I would specify it into vector category. As we are going over vectors, when represented by an arrow, I can say this represents a vector quantity because it points at a direction. Another thing to consider is, what does the arrow's length represent? If this arrow over here represents my direction, then the length represents the magnitude of it. In this case, I have both my magnitude, represented by the length, and my direction, therefore I am dealing with a vector. I can also understand this by its notation. Whenever you have an arrow on top of that AB, or the letter can change, but whenever you have that arrow, that indicates direction is involved. If I want to find the value of its magnitude, I can take the absolute value of my AB for this arrow, and remember that the value I get for magnitude cannot be 0 or negative, and that is why we take the absolute value of it in the first place. We can also have two vectors that are opposites of each other. So what this means is we take the opposite of what we have in this case, AB, and flip it. AB's direction is northeast in this case, for this one, but while my opposite could be southwest, right? It would be southwest. And these vectors are called opposite vectors. And changing the direction also leads to changing the signs. The first thing I change is the letter format. So instead of going from AB, we started with B and then goes to A, but we also change it to negative. You can think of it in this way: if my main vector goes in the positive direction, right? Like this one, it goes into the positive direction, then the opposite will go in the negative direction. Therefore, I need to put the negative sign. It goes to the negative portion. If we were to put the same concept to coordinate system, we would get something like this. So if I have the coordinates 2 and 0, that gives me that my x value is 2 and y value is 0 because it does not go into the y direction. It doesn't have a y component to it. So when I'm calculating the magnitude of this, all I need to do is put it into the absolute value, which would give me a magnitude of 2. Same thing over here. It doesn't matter if it's going in the negative direction, and I have the coordinates -2 and 0. Because the magnitude is the same, I don't care about the negative portion of it, because when you put it into the absolute value, you get the same magnitude. In order to determine if we have equal vectors, we need to satisfy two conditions. Condition 1 is AB and CD are parallel to each other, and the direction from A to B is the same as the direction from C to D. So that means I know these are in fact parallel to each other, and they both go in the same direction, so it goes into positive direction. So I do satisfy to find the equal vectors. The second condition, however, is the magnitude of AB equals the magnitude of CD. So that means the length of my arrow over here needs to be the same as the length of CD. Also, it is important to note that we can represent the vectors by lowercase letters. Instead of saying AB or CD, you can just say P and put an arrow on top of it. Let's solve a problem to understand different types of questions we can get on this section. Square ABCD is drawn as shown over here, where they're intersecting at the point E. They want us to state 4 pairs of equivalent vectors. I know that from the previous slide, I have two conditions if I want to get the equivalent vectors. First, they need to have the same magnitude, they need to have the same direction, so I will look for those two, and they need to be parallel to each other as well. So over here, what I realized that satisfies this condition is if I look at AB, so I'll just write AB, and this is the part A of the question. For AB over here, it's parallel to DC. I look at the magnitudes as well. Since this is a square, those two sides are also equal to each other, right? And they also go in the same direction as well. So I will say AB will equal to DC, right? So that's one, and I'll look for others. So I see what else is parallel. AD goes like this, which is parallel to BC. I see that it's the same magnitude as well as the previous one we did, and it goes on in the same direction as well. So I will say BC will equal to AD. Now let's look at 4 other ones because it says 4 pairs, right? What else is parallel and has the same magnitude? I see that my A to E goes like this, and my E to C also has the same magnitude, and it goes on to the same direction. And if I actually take this and put it right next to it, it will be parallel to each other, right? I already know. So that's also another pair I can put up. So AE will equal to EC. The last one would be over here. The same thing, my DE goes like this, while E to B goes like this as well. Same direction, same magnitude. So I will just say DE will equal to EB. For the second portion, it says state 4 pairs of opposite vectors. So when I look at here, I see that all of them in fact goes into the same direction, right? And if I want the opposite vectors, that means I also need to have the same magnitude. I cannot just take AE and DE because they wouldn't be really opposite to each other. I need them to go in the opposite directions, right? They all have the same magnitude right away. What I can do though is take the exact same things, the equivalent vectors, and switch one of them and make one of them the opposite vector by putting the negative sign in front. So just flipping them like I told you guys. So I'll keep AD, and for BC, which is right over here, what I'll do is I'll take the opposite vector of this so that it goes from C to B. Now when I take the opposite vector, what I do is first I change the letters, so it now goes from C to B, but then I put the negative sign in front as well because it's opposite, so negative CB is my answer. Same thing with this one, I have AE equaling to EC, but let me just switch EC to opposite, which goes from C to E. So now I have CE, but I also need to put the negative sign in front. I do the same thing for the other ones. By the way, you don't have to switch the second ones. You can literally keep BC and change AD as well. So I can make DA, negative DA equaling to BC as well, doesn't matter. And I'll do the other ones as well. For the last portion, it says state two pairs of vectors whose magnitudes are equal, but whose directions are perpendicular to each other. So when I said the magnitudes are equal anyways, I meant over here, let's say the inside ones are equal to each other. However, these ones have different magnitudes, right? So for these, since it wants equal magnitudes, I'll start from inside and see which ones are perpendicular to each other. I see that from A to E, if I go like this, what's perpendicular to it is AE to B. So they do have their directions perpendicular, but they also have their magnitudes same, equal. So I can just say AE pair and EB pair. So that's one. You can go ahead and do other ones as well. Such as, I don't need to only take this one over here. I can actually keep going and say A to C. And if I do that, what's perpendicular to AC, it's DB, right? I can say AC and DB is also a pair. You can go ahead and do more, it doesn't matter. If you want to go outside of it, and since you understand the insides, because you can take more pairs, you can have more pairs. So let's say AB to BC is also like that. Their directions are perpendicular and have the same magnitude. Same thing with, let's say, EC to DE, right? Those are perpendicular to each other. So you can really make more pairs, but it's only asking for two pairs of vectors, which we already found. Now, James is running around a circular track with a circumference of 1 kilometer at a constant speed of 15 kilometers per hour. From here, I know James is running in a circle on a circular track. We got that, and the circumference of it is 1 kilometer, and he is going at a constant speed of 15 kilometers per hour. This constant speed means whatever point he's on over here, he will always run at a speed at 15. His velocity vector is represented by a vector tangent to the circle. So it means these two. So these are the vector tangents. Velocity vectors are drawn at points A and C, as I circled. As James changes his position on the track, his velocity vector changes. Why that happens is, let me just erase this. Why that happens is, remember how speed is different than velocity. Speed does not have a direction, so it makes sense that his speed is 15 kilometers, it's constant. However, velocity changes because he runs in a circle where the direction he's running to always changes. So at point A, he will go in this direction. At point B, the vector, the direction he will go to is here to the west. And at C, it's as shown, and at D, he goes in a different direction, which is towards east. So like I said, his direction always changes. It's important to understand what they're going to ask us in this question. Now it says, explain why James' velocity can be represented by a vector tangent to the circle. This is because the tangent vector given actually describes James' velocity at that moment, like we said before. It gives us his direction and the magnitude of it at that point specifically. So let's say at point A, his speed is 15 kilometers per hour, but he's also heading north. So it basically, the tangent vector shows his velocity at A would be 15 kilometers per hour north, and at C it would be like 15 kilometers per hour south. and that's why James' velocity can be represented by a vector tangent. The second one is asking, what does the length of the vector represent? Like I said, it represents that 15 kilometers per hour, the speed, so James' speed, so we can also say that. For part C, we already kind of explained it. As he completes a lap running at a constant speed, explain why James' velocity is different at every point on the circle, which we explained it as because he changes the direction at every single point. It's not the same. At B point, right, he goes west. At point D, he goes east. You might be asking what happens in between. Well, he goes in a direction where it's northwest, so it will go something like this. So whenever you want to find the velocity, just draw a tangent to the circle, right? So we can just say the magnitude of James' velocity is constant, but the direction of his velocity changes at every point. The second one is asking, determine the point on the circle where James is heading due south. I can say it is at point C because it just goes south. Now, for this question, it says, in running his first lap, there is a point at which James is traveling in a northeasterly direction. If he starts at point A, how long would it have taken him to get to his point? So I know he starts from point A, which moves north. So all I need to find is where does that northeasterly direction occur? If he starts from A and starts moving up to north, he will come to this point, which has components of north and west. So this is northwest direction. When it comes to point B, he moves west, so that's not the direction I'm looking for either. So I move along again, I come to this point, which is west-south, so southwest direction. He comes to point C, he moves south. He keeps moving on. Over here, I see that if you put an arrow, you see there's a south component and an east component to make that arrow true. So it's southeast, so it's not there either. At point D, he moves east, and I move on again. At this point, I see that I have the north component as well as the east component. So that's northeast direction. That's the point I'm looking for. Now, because it says how long, I need to consider his speed, which is 15 kilometers per hour, and the circumference, which is 1 kilometers, right? What I can do to make it easier is try to figure out how long the path is for each quadrant, right? So for that, I can just divide 1 kilometers by 4 to figure out how long is this path. And if I do, I'll get a value of 0.25 kilometers. So that's how long each quadrant is. So if he is at this point, I can already tell 0.25, 0.25, and 0.25 will give me 0.75 kilometers. I already have that. The only thing I need to find is right over here. So I also need to take into account how fast he is. But because this is in hours, I'm just going to change that to minutes to make it easier, because probably that's what's going to happen. He will run in minutes. The answer will be in minutes. So 15 kilometers per hour. Let me change that to minutes. So we say in 1 hour, I have 60 minutes. That way, let me get my pencil. That way I can cancel out my hours, and I'll get a value of 0.25 kilometers per minute. So what I actually found over here is per minute, James goes 0.25 kilometers. And I know over here, he goes 0.75 kilometers plus the half, which if I divide 0.25 by 2, it will give me 0.125. So the total distance he goes through, total track, is 0.875 kilometers. So there's really like two ways you can do this. One, logically, if he goes 0.25 kilometers per minute, I already know when he's at point D, it's been 3 minutes. And if I want to add the half of the minutes, then it takes him 3.5 minutes to get to that point. Or as a second way, you can actually use math and say for per 0.25 kilometers, right? If he goes 0.25 kilometers per 1 minute, right? How long does it take for him to go for 0.875 kilometers? And I don't know my minutes, right? Put the kilometers on one side, put minutes on the other side, or whatever the time is. What we do is we cross multiply to find it. So I multiply 0.875 with the minutes, so I will get, because it's 1 minute, so I will get 0.875 kilometer times the minute. And this will equal to the other multiplication, which I'll just call this x because I don't know the value of it. And my x would be x times 0.25 kilometers. Now I'm trying to find the x. So in order to isolate the x, I'm going to divide each side by 0.25. So dividing 0.875 by 0.25 will give me 3.5. And remember, when they're divided, kilometers get cancelled by 2, and I get 3.5 minutes. So you can do it both ways, but that's it for that question. At the point he has traveled 3/8 of a lap, in what direction would James be heading? So assuming he starts at point A. 3/8, if you put it into your calculator, equals to 0.375. Okay, so that means when he travels 0.375 kilometers, right? I already know for each quadrant, for the lap I have, it's 0.25 kilometers. And I know when I divide this by 2, right, to get the value of the half of the lap for the quadrant, I get a value of 0.125. Now, if he went for 0.375 kilometers, I can add 0.25 to 0.125, so I can add them together to get a value of 0.375 kilometers. So that's actually my point, right? So all I need to do is find the kilometers over here and see where it's at. And I know it's at this point. Where does he head at that point? So it goes like this. I have a south direction and I have a west direction, so he goes southwest. So AB is a vector whose tail is at -4 and 2 and whose head is at -1 and 3. Now the point they're talking about is -4 and 2, which is right over here, and -1 and 3 occurs right over here. Now if the tail starts from -4 and 2, then it would go right like this. For me to find the magnitude of AB, which is the first question, I need to figure out how long this arrow is, right? And I can actually find that by using the Pythagorean theorem. So I can find the components of this arrow. One of the component is when it travels to the positive direction up to here, and there's also the y component when it travels the positive y direction to make this arrow, right? And I know from here, between -4 and 1 is the magnitude of the x component. So the x component is basically, you can think of -4 minus -1, and that will give you the value of this, and that would give me a value of -3, but my magnitude cannot be negative. So this is basically a magnitude of 3. Same thing over here. What's between 3 and 2? We need to figure out the magnitude of the y component. So I just do 3 minus 2 to get a value of 1. So the component of the y, the magnitude of y, is just 1. Now from the Pythagorean theorem, what I can do is, what we did is we take the x component, which is 3, square it, and then we add it to the y component squared, and then we equal it to, let's call this x, right? And then we equal it to that, which is x squared. Now, to find out what my x is, not x squared, I can just take the roots of each side to get a value of x equaling root 3 squared plus 1 squared. And that would give me a value of root 10. So that would be my magnitude for AB. Now the second question says, determine the coordinates of point D on vector CD if C coordinates is -6 and 0 and my CD equals AB. What this means is, remember the equal vectors, this does not just mean magnitude, it means the direction, the magnitude, and they need to be parallel to each other, right? So if my point C is given to me as -6 and 0, then I don't know the coordinates for D. What I can do is use the components that I found, x and y components, and draw a vector depending on that. So what we will do is we will add the magnitude of 3, and because it needs to be parallel to each other, it needs to move in this way, same as this one. So I cannot just add the magnitude of 3 to the other side as like that. So we're gonna add 3 for the x component. So when I add 1, I come to -5. When I add 1 more, I come to -4. And me adding 1 more will bring me to -3. So one of the components is -3, x component. And if I move up 1, it will bring me to when y equals 1. So actually my vector is this. And if they want the coordinates for D, that is just -3 and 1. That is the point right over here. Now, the part C is exactly the same one as B, so I'm not going to do it. You guys can do it on your own. The last one I'm going to do is D, which is to determine the coordinates of point G on vector GH if the coordinates given to me is 1, 2, 3, 3, and 1. So it's right over here is my G point. And I know my GH is the opposite of AB. So opposite means that my vector is probably going to go like this. That's -AB. Since I'm going to add, the magnitude is the same because it equals to each other, it's only the direction that changes. Then I'm going to add the x and y components that is the same, but instead my x component will move this way, 3, and my y component will move the other way. So instead of going positive y direction, it will start going negative y direction because of the negative sign. So if I actually do that, me moving 3 will give me the x component, its coordinates 0, and y component, if I do -1, it will give me the coordinate 0, 0, and my vector will be this. If you have any other problems that you would like us to solve, make sure to go to our website and visit the forum section.